All right, so a machine produces open boxes using rectangular sheets of metal measuring 15 inches by 8 inches. The machine cuts equal sizes squares from each corner, then shapes the metal into an open box by turning up the sides. Express the volume of the box in cubic inches as a function of the length of the side of the rectangle cut. Well, I guess it would be the square for each corner, so I apologize about that. But this is a rectangle. The shape is a rectangle here. Okay, so the shape's a rectangle. That's my bottom. And what they're doing is they're cutting a certain amount from each side. So it starts as an 8 by 15 rectangle, but they're cutting a certain amount from each side. Okay, and they're cutting it from both sides. Okay, so I've got to come up with an expression to express what my dimensions would be as I cut an equal amount from each side. So if I'm cutting it from two sides, that'd be two different values or two values to the same values. And if I'm cutting them, I'm taking it away. So it'd be 8 minus 2x. Because subtracting because I'm taking it away, and then 2x because I'm cutting it from both sides. So this would be 15 minus 2x. Okay. Okay. So next, what I'm going to do is I'm going to determine an expression for the volume. So the volume, recall, is length times width times height. And so the volume would be the basically one dimension times the other dimension times the height. We'll get to that in a moment. So 8 minus 2x times 15 minus 2x. And then the height, how tall it would be, well, you're cutting that x is the amount you're cutting from each side. So x would be the height. Okay. Now, I don't know if we need to multiply this out. You could leave it like this here. Okay, this is the volume. We'll just leave it in this form and actually kind of help us on this as well. So find the domain. So the domain, we got to think about values of v that you could have that would make sense for this situation, or values of x, I'm sorry, values of x that make situation for this volume, okay? So first off, well, let's see, where do we start at? Let's think about where we would start at. Well, if we started at, we wouldn't have a negative x, we wouldn't have a negative amount cut from each corner, but let's say we started at 0. So could you have 0 cut from each corner? Well, for it to be a three-dimensional shape, theoretically, you wouldn't have 0, but you would have something over 0. So your domain would be starting at 0, but not including 0. So then our Okay, so now how large can X be? Well, the key is on this, we want to look and see, we can't have, this can't be so large that it would make any of these dimensions technically be negative, okay? So what I would need to do is, I would need to find the smaller of the two dimensions here, and I would set that equal to 0. Okay, because I want to see the max x be. Now, you probably could do this in your head. So subtract 8, negative 2x equals negative 8. Divide by negative 2, divide by negative 2, x equals 4. So we solve this, x equals 4. So now, if x were to equal 4, that would technically be 0, which wouldn't be possible. Now, it could be like 3.9999999 and repeating. So that would set 4 would be, it couldn't reach 4, but it could reach up to 4. And so it'll be at least more than 0, but less than 4. So that'd be our domain there for our values of x for this situation.